Hello, and good morning, good
Hello.
afternoon, good evening, everybody, and thank you for joining. Hi, Jesus. How is it going?
It's going all right.
It's
How are
going
you?
very good, very good. I'm looking forward to this. It's already a sixth episode, so I
Yeah,
was just I just did a double check if I didn't mess up the numbers because I thought it cannot be. This
can
must
you
be a lower
believe it?
number, but it is actually it is
Does
actually
that mean
correct.
that we've been doing this for half a year now?
It
That's
yeah, that
pretty
exactly
amazing, yeah.
means this is what exactly what it means.
That's
Yeah.
brilliant. No, really, really happy. I mean, I'm really enjoying it, and I think we're running some pretty cool sessions, and yeah, I hope it's been interesting for you too.
I hope so too. For me, it definitely is interesting. I hope you enjoy it as well. And obviously, you, the audience, is every time invited. I just posted it in chat, and I wanted to reiterate on that. Is It's interesting if you interact, if you let us know what you are working on at the moment, if ontologies are something that you are working with, if you have questions on that, if you have opinions, if you have anything to share on that topic, always post it in chat. We try to make detours and look into that or discuss things further. So it's definitely not supposed to be a one-way street where we or Jesus rather is talking to you, and then you go back to what you've done before. But if you have anything to share, anything to as a discussion point, then it would be obviously nice to hear this. So don't feel like this is not the right place or this is not the right format. It definitely is. So if you have anything to say on the topic, do
Yeah,
so.
and the idea was I don't know how it happens on other broadcasts or streams that you do, but yeah, the idea was for it to be as interactive as possible. And of course, for those of you who watch it offline, there's plenty of channels to get in touch. But comments on the video, get access to us in the community portal, Twitter. Anyway, it would be great to hear your thoughts and ideas for future sessions or comments of any kind. Absolutely, we love comments and we love the
Yeah,
discussion. So that's
yeah.
totally.
Good. With that, the topic today is on ontology learning from graph data, and when we were thinking about that topic, I think I made the first mistake, and I think maybe we should probably discuss it a little bit because I said, hey, why don't we call it ontology training, because that sounds more interesting to me. And then you said ontology training is something completely different.
Well, training in general, right? Is
Yeah,
model training is like
yeah,
probably has connotations on more on the machine learning side of things. Where so yeah, no, and to be honest, I mean, one of the things that I really like about these sessions is that we're not really how would I put it, very fixed on terms and on names. I mean, we're going to show what we're going to do. We're going to try to learn from our data and make it explicit, learn
Mhm.
from a data set. And, I think a reasonable way to call that is learning. Maybe there are other formal terms to describe the process. But yeah, I thought maybe the idea of training might be a bit confusing. But yeah,
Yeah.
I hope that, we'll be the session will be expressive in itself, and you'll get value out of it. And if you think this is learning an ontology, which I believe an ontology, a taxonomy, a concept scheme, learning from your data and making explicit these learnings, that's what we're trying to do today. So that's the idea. So not a mistake, Alex. I mean, we try to describe things, and
No.
sometimes you use different terms. So that's
Yeah,
right.
yeah. No, that's yeah.
This is one like like knowledge graphs, right? So if we counted the many definitions of them, so what matters is
True.
what you do,
Yes.
what problem do you solve, what sort of so that's what we're doing today. And like I say, I hope it will be interesting and useful for some of you.
Mm, I'm pretty sure, and that's always like with these terms, they have the special meaning in certain contexts, and I think we talked about context when the first session actually was about context and
Yeah,
where how to you know to bring context and what does it mean in certain
yeah,
um, surroundings. And I guess this is another learning training. It could be a similar word or a synonym in some regards even, but in different contexts it means different things. And then you have different expectations of what it is and what it does, and then you end up with something else entirely just by switching out a word that is. If you talk to somebody on the street, they probably say, "Yes, it's very similar."
True. So I'll try to. I don't know if I think I'm not sharing my screen yet, but
Not yet, no.
I'll try to use my the first slide to describe and like you were doing, Alex, to show how these kind of connect with one of the previous sessions. So I don't know if I'm sharing. I'm going to get this out of the way, and hopefully we can see. I will probably go on full screen, and you tell me if everything's still looking fine, because I'm only going to need the browser today. But yeah, the title, we've called it Ontology Learning from Graph Data, but ontology might be, for some of you, maybe too formal. I mean, it's essentially we're trying to learn a way of classifying data. So that's I'll go to slide 2. Might need to. Don't like going to full screen because then I lose control. But the idea is, we want to really categorize a data set, and that connects, like you were saying. I believe I don't know if you referred to that one, but the session 2 was on semantic search, right? And we have I think it was like
session 2. I meant session 2. Yes,
exactly. Articles, and we had an ontology that existed already. We linked the two things together, and then we could do clever searches and recommendations and things like that, right? So in that one, we started from the assumption that someone has created some domain experts, like I call it there, that understands the domain, has created an ontology, a classification, a taxonomy. I believe in that case we took it from Wikidata or something like that, right? So we already had like a classification of software systems, right? There was databases, there was programming languages, there was, and subcategories. So that existed already, and someone had created that. And in Wikidata, that's a collaborative effort, but it's a human, a manually, a curated effort. So you describe the domain and you classify it based on your understanding. And then you have your data aligning to that existing ontology. So that's one approach, and that's absolutely fine. And maybe we'll touch on how we approach the creation of an ontology from that point of view, like the manual modeling of a domain. But what we're doing today is a different approach. It's like we have a data set that happens to be enriched. It's already annotated. And it's, what we're going to do is, can we learn from that data an ontology, a taxonomy, or at least can we get an embryonic form of a taxonomy that maybe some expert can take and use or modify or curate and make it a real one. But that's the is it clear? Does that make sense?
Yeah.
So and for that we're going to use a data set, a public data set that I've taken from the Goodreads site, maybe an old screen capture, because this is an experiment that ran a few years ago. But the idea is that you have, this is just a page, a description of a book, and you see that to the right. It's interesting on that side because this box to the right that describes the genres is actually open. I mean, I can comment. I mean, I can say how much I like that book, and I can give it my own tags, and that can be my personal classification. So I can call that these are books to read on a Sunday afternoon, or to read while you have a beer or something. So the categories are completely open. It's not. I mean, no one has enforced. I mean, maybe there's some elements that you can choose from, but you're totally free to tag and annotate things the way you like. And what's interesting is that other people can come and say, hey, that's right. I mean, that's a book for a Sunday afternoon. I'm going to tag it like that. So it's kind of a collaborative effort, but there's no notion of structure there. It's just tags. So it's a thing that maybe has a meaning for someone who reads that, but there's no structure, no taxonomy, no classification, no organization around it. And that's exactly what we're going to try to work on today. So that's the data set. And before we move any forward, and before we look at how we're going to approach this extraction, let's look at how we load that data. And to do that, I have created, and that's why I don't like the full screen, because then, I mean, there must be a way of keeping the tabs. But anyway, I'm too bad to that. So what I've done is I've created, of course, I've instantiated a sandbox, an empty sandbox, just minutes before the session. So it's an empty database. Anyone can, if you want to play along, you can do that. But what I'm going to do is I'm going to load the data from this extract that I've taken from Goodreads. Is now in the usual GitHub repository, session 6. there's in the data folder, we have 2,000 books. So it's a small data set, enough to work today. And if we click on it, I mean, we will not get the preview because it's a large CSV, but we can use the link as usual. So we can copy the link to the raw one. Don't take this one as usual. So we copy the link address, and we can preview what that looks like with a simple load CSV from, and we can use the URL as row, and that would return, maybe we can return the first 10 rows to see that we have connection. Might take a while because, this is all, one side to the other. I didn't put the headers. I mean, I didn't indicate that there were headers, but there are. You see what we have, right? It's pretty basic information. So for every book, we have the title, we have the author, we have a set of genres, which is exactly what I showed before. And you see that it's a comma, semicolon separated list of genres that people have entered, and they happen to be prefixed with the genres slash. So we'll remove that when we load. And we have some additional information like the description, which we probably will not use for today's session, which is a blurb of text. And then we have the URL that uniquely identifies it, and that's pretty much it. So what we're going to do is we're going to load that into the graph, and for that, instead of typing it and making mistakes, I'm going to copy it. But and it's going to be a simple, very simple model, just books, genres, and authors, right? And in order to use that, I'm going to create 3 indexes. I mean, it's a small data set, and we probably will not notice the difference. I'm going to create an index on the author's name, on the book ID, and on the genre name, right? All the code, as usual, is going to be available on the GitHub repo, so don't worry about following now because it's going to be there for you to take. So we have the schema, and let's look at what the load CSV instruction would look like. So I'll paste it here. Maybe have a quick look. But again, we point at the file that I just mentioned, and I'm creating books. So that's the first node. And on the book, I'm copying the description and the title, right? So there's these 2 properties, and identify it with the URL, which is the pointer to the page that we just saw. And then we iterate. Remember that the genres was a semicolon separated list of values. So we split it on the semicolon. We iterate over each of the values, and we strip out the first few characters that was, remember, what was it? It was the genres slash blah, blah, blah. So I remove these first 8 characters and just keep the name of the genre. I instantiate a node and link it to my book with the has genre relationship, right? And then finally, I take the author. It looks like we can have multiple authors for books that have multiple of them, and we just link them to the book as well. So the book gets linked to the author. So pretty straightforward. I don't think there's anything special about it. Of course, we will end up. I mean, let me run that. It should take only a few seconds because it's just couple of thousand lines, but we should hopefully, and that's the idea, because we're using merge, we're going to have many books sharing, of course, sharing genres, many genres shared by books, and the same with authors, right? So the moment this ends, we're going to explore the data set. Of course, if you run it locally, you will have a very different experience. This is kind of streaming the books over my, well, shouldn't take very long. And once we have it, what I'm going to do is give you a feel of the average number, the maximum, minimum, and average number of genres. Here I have the book coming up. There you go. So we have all the books created, and I don't know if we pick, if we do a click here on books, we see that we have Romeo and Juliet there. If we expand it, we will have, oops, I don't like the auto connecting. Let's do this again. So let's take Romeo and Juliet, and like this, we see that it has a number of genres that people have entered. We can make that a bit bigger to make it readable. So we see that it's a drama, poetry, classics, plays, fiction, and so on and so forth. And it has 2 authors, interesting, not only Shakespeare, but also Robert Jackson. I mean, let's not worry too much about the the data, but that's what's downloaded from that page. But that's the model, right? And
Yep.
if we expand, I mean, I don't know if I expand Les Miserables here. There we go. We see that they share some genres, so both the classic, literature, fiction, and so on and so forth.
Yeah.
Right. So that's the model. If I run this query that I had prepared here, this will give us the average number of genres per book. So 5.8, although we have some that have as many as 10 and a minimum of 1. So the query is, again, pretty straightforward. I just do an average, max, and min just to get an idea of what the data set looks like. Okay, so we have the data, and we want to we want to use the genre information to create a classification. At the moment, it's just independent nodes, right? We see them that they're linked to books, but there's no structure around it. So I thought, the first thing that we could do is, why not? We have GDS, and the Graph Data Science Library has a node similarity algorithm that we could try. Why not? I mean, that should be an easy way to do that. So in Sandbox, we have GDS pre-installed. So I'm going to quickly show you how, first we need to create a projection before we start running the algorithm. And I'm going to use the simplest projection that basically it's a replica of my actual graph. I'm only going to be working on the genre, so I'll ignore the authors. And what I'm doing here is I'm creating a projection that I'm naming book similarity graph. I know that I was talking about genres, but I'll do it in 2 steps. I'll first do book similarity because it sounds like the most intuitive approach, and then I revert it to show how we go about doing it for genres. But the way I create a projection is pretty simple, right? I give a list of the labels that I want to project, that I want to analyze in my algos. And like I said, I'm going to be working on books and genres. I only want to project one type of relationship, which is the one that connects book to genres, which is has genre. So that's how simple it is. So if I create this projection, it will take this portion of the graph, bring it into memory, and that's it. So now we can run our node similarity algorithm, and all we have to do, I can actually type it here. So I can say call GDS, and we have node similarity, and I'm going to stream the results out. And all I have to pass is which projection I wanted to work on. So I wanted to work on book similarity graph, right? And this will return node 1 and node 2, pairs node 1, node 2, and similarity score. Then these are actually node IDs. So I want to convert them to actual nodes by using the GDS util function. It's called snode. So the snode function takes a node ID, node 1, and will return the node. Because this is going to return books, I can probably get the title. And I'll do the same with the other one, GDS util snode 2, and I'll get from this node the title. So these two are similar books, and this is the similarity score. And I'm probably going to limit it to the first. I actually want to order by similarity, descending, and limit it to, I don't know, to the first 50. So if I run that should be pretty quick, and it will compute similarity between books, and we get pairs of books, right? And because we select the top, we get the ones that are most similar, the ones that are similar, and probably this is based on the fact that they share exactly the same set of genres, which is all I'm looking at this point.
Yeah, that's all we had right in our graph. We don't have any more information.
Correct. In the projection, I mean, we could look at authors. We could have.
It's true, we had the authors as well, but
we only looked at the genres. So that's why. But that's probably the most natural. It was for me when I was trying to use this node similarity algorithm. But what I want is exactly. I don't want similar books. What I want is similar genres, and 2 similar genres. It might be a bit less intuitive, but basically, 2 genres are similar if they contain the same set of books, right? So if everyone, let's put a silly example, but if everyone tags every poetry book with a book that you would read on a Sunday afternoon, I would say that there's a strong similarity between these two genres, these two categories, right? Sunday afternoon book is very similar to a poetry book. So I want to do exactly this kind of similarity, because that's the kind of thing that I'm going to be using to structure my genres and try to create this classification, this organization scheme. So it's pretty straightforward. Is actually, I'm going to copy it from here, but the syntax is identical. I want to create another projection, and that we can have multiple projections. We can have a catalog of projections on Neo4j. And look at the small detail. It's still books and genres. It's still the has genre relationship. But I'm going to say, look at the relationship in the reverse orientation. So instead of going from book to genre, I'm going to go from genre to book. And I'm going to create a different projection, right? I call it, instead of book similarity, genre similarity. So I create that one. We have a second projection now. And actually, we can always look at all the projections with lists, right? Is that it? And we see, oh, that's not, that lists all the methods. That's not what I wanted to do. What I want to do is GDS projection. Is it list? Oh, that's.
I'm not sure. I don't know.
Well, we should get. I mean, that's bad of me. List. There must be graph list. Is that the one? Graph name. Well, I'll find. That might not be the one, right? So it's. Yeah, that's it. So we have the book similarity graph. Yeah, and we should have the genre similarity graph. So that's the one. So it's graph.
Okay. Yeah.
Yeah, we're not. I don't know if we're looking at the last version of yeah. So yeah, so I was going to do exactly the same thing, except that now when I call the algorithm that similarity algorithm that I called before, instead of calling it on the projection on books, I'll call it in the projection of genres. And of course, what I'm going to return is pairs of similar genres. So instead of getting the title, I'm going to get the name, because that's the property that genres have. The idea is pretty much the same. So it tells us that in our data set, research is very similar to Eastern philosophy, poetry, plays. There's pairs of things that, maybe not, you see how the number decreases after a certain moment, but you see that, Japanese literature. So there's things that are obviously connected, and you can see that there are different things, different ways of tagging probably the same books. And so that could be one way of doing it, right? So we could, why not, right? We could materialize some of these relationships, and we could say, nothing stops us from creating something like a similar to relationship, right? So if we say, it might not be the richest classification, but we can say something like this, right? So from if we get the first genre, let's call it G1, and instead of returning, I'll do a with. Let's not use a property. I forgot the as here, right? I could say, well, why not linking them? And actually, I could get actually the similarity as well. And I could say, well, why don't we merge and connect G1 with G2, and say, well, these two are similar, right?
Yeah.
And we could even store the score, or something like that, and say that this is similarity. And maybe not all of them, because sometimes maybe the lower level ones, maybe we can say just with that where similarity is above a certain threshold, right? We can say if that's over, what do I know? For example, anything over 0.6.
0.6, yeah.
And of course, we're just showing the idea. Probably we have to put a bit more thought on where to put the threshold.
Yeah, but it's not we're not doing a
But exactly, but if we do
recommendation system or
something
something.
exactly something like that, we can now create a bunch of relationships, and we have a first classification, right? So I mean, it's not really a classification. I would say, oh, I should have excluded, so that I only have it in one direction, because obviously this is going to probably be identical, but doesn't really matter. The idea still holds. So we have, a set of connections that can help me understand my tags, right? So something that was implicit on my books being tagged similarly, I can surface and say, well, look, when you're browsing, let's say in the Goodreads catalog, you're looking for metaphysics. Maybe we could suggest, and we can say, hey, have a look at academic, because there's a significant overlap, which is on which this algorithm is based, and maybe you want to find interesting books on that category as well. So this is one possible way. So I agree that this is, you might say, well, that's maybe too simple. I agree. Let's move on to the next approach. But that would be one idea, right? So one way of extracting and adding more, I would say, surfacing a structure and well, making explicit some latent relationships. So there's a connection between these genres. We can make that explicit by learning it from the data. One important thing, and that holds in any case, this is obviously driven by my data set. So in my data set, we have a very strong connection between graphic novels and comics. Well, in this case, it's pretty similar, right? But memoir and biography are not necessarily synonyms. There's a significant overlap, significant similarity, but this is based on my data set, and that's something that we have to keep in mind. And maybe we need to make sure that the data set is balanced or extended, or keep refreshing this taxonomy, because if the data set is biased, I might be deriving some relationship that might be unexpected. So that's an important thing when we are learning from our data. And what I was saying at the beginning is that might be some hints, some ideas for someone to then come and put some structure and curate that knowledge in a formal ontology, maybe. So that's the first approach. But we're gonna delete this. So we're going to delete these similarity relationships that we've created, and get back to our original data set. So we've deleted the 42 that we had created, and I want to go a step further and try to learn not just point-to-point relationships, like this is similar to that. I want to try to learn a taxonomy, right? So this is a broader term or a narrower term than this other one. And to do that, I'm going to follow a simple algorithm that we came up with a while ago. Let me see if this is readable. So it's just a couple of slides, but I'll get back to the. Is that readable, Alex? Is that good?
Yes, that's good.
Perfect. So that I mean, we've seen the data set, right? And we see that there's this idea of co-occurrence. So we have we define co-occurrence as the set of books where two genres, or two tags, if you want, are shared, right? So fantasy and dystopia happen to be common to a number of books. So there's a co-occurrence of these two genres of three. I mean, there's three books that make the two similar, but there's some that are not shared, right? So let's see, how do we interpret that? Because that precisely is something that we want to take into account and define a directional similarity. What do I mean by that? Let me go to the next slide. So I define this co-occurrence score as well. It's a very simple formula, but it's like it's similar to the Jacquard idea, but it takes into account these intersection and non-intersection. So if we look at dystopia and fantasy, we see that the overlap is exactly the total number of books of type dystopia. So if the formula is the overlap divided by the number of books, or the number of elements in the data set tagged according to 1. If we do it in the other direction, fantasy to dystopia, we see that the overlap is exactly the same. The intersection is still 3, but the total number of fantasy books is 5. Therefore, in that direction, the overlap is slightly smaller. Does that make sense? So of all the fantasy books, only 60% are dystopia books. Whereas of all dystopia books, all of them are fantasy books, right? Does that make sense? I'm not hearing you. I hope that's a yes.
Yes, that's a yes. That's a yes.
Yeah.
Yeah.
So, and that's
Yeah.
exactly the idea. So we're going to first compute this kind of directional similarity that was not captured by the algorithm before, and by doing that, I'm going to know that that there's a strong similarity between the two, but it is somehow stronger from dystopia to fantasy than it is from fantasy to dystopia. And then I'll apply a very simple rule, which is, well, what happens if the overlap is exactly is the same in both directions and it's equal to 1? Then that means that the two tags are synonyms. They're identical, right? If every book that's tagged as dystopian is also tagged as fantasy, well, the two things are maybe two ways of calling the same thing because they apply to exactly the same set.
Yeah.
But if it's the other way around, I mean, what we can derive, and I put derive in quotes because, of course, this is not formal derivation, it's not formal inferencing, but it's kind of a heuristic approach. I can say that probably dystopia is narrower than fantasy, right? Because, as we saw in this example, every book tagged as dystopia is also tagged as fantasy, but the opposite is not right.
Mm-hmm.
So, in other words, the dystopian books are a subset of the fantasy books. Therefore, dystopia is a kind of a narrower category of than fantasy, and that's what I'm going to. Does that make sense?
That makes yeah. That is.
Let's see. I mean, let's apply this kind of intuition, this kind of heuristic, and let's see what that returns, because that's what we're going to do next, right? So if I get back to my data set,
in essence, this would create a subgenre without having the label subgenre in the first place. So we would, like you said, we would derive subgenres, sort of. Is that what it is?
We're going to learn relationships between the genres. So what we're doing. I mean, let me put the cipher here so that I don't make mistakes. But I mean let me. Yeah, I don't know if I want to copy it. I'll copy it and explain it. Hang on. Here we go. Sorry, jumping from one screen to the other. But that's what let me dissect these.
Mm-hmm.
So we're looking at, as in the screen before, right? We're looking at these, we're taking pairs of categories, pairs of genres in our case, and we're going to compute what's their overlap and what's the non-overlap, what's the bit that's not shared, right? And we do that in Cypher very easily. So we take, for first we find all possible pairs of genres that have at least a book in common, right? And this is this pattern.
Yep.
So genre 1 has a book, and this book is common to genre 2. So with that, I get a distinct list of pairs of genres, right? Yep. This trick here is just a simple way of not having what we had before, right? If we have G1 and G2, we're also going to have G2 and G1, and I don't want to have that because I want just a list of all possible pairs. So that's what I do with this trick of getting the ID greater than the other. But once I have all these pairs, what I do is I take, okay, what's the degree of the first one? Well, how many books are in that category, in that genre? That's degree 1. I call it degree 1, right? That's the number of books in this genre 1. Then I do the same with genre 2. So this would be the total, right?
Mm-hmm.
So essentially what I'm doing is I'm computing for dystopia, these 3 books, for fantasy, the 5 books that connect directly to it, right? And then I compute the intersection, the overlap, right? And the overlap is the count of books that have both of them, G1 and G2, right? So the 3 in common. And with these 3 values, with degree 1, degree 2, and overlap, I can compute the formula that I was showing before, right? So if I get back here, all I need is the intersection divided by the total for each one of them, and that's exactly what I'm implementing here. So I say that the directional co-occurrence of G1 and G2 is the overlap, which is always the same because that's common to both, but this is divided by the degree of one. How many books are in one? So what percentage of all of those is common to G2? And I put it in my co-occurrence score from G2 to G1. And then I do the same from G2 from G1 to G2, but you see that I've inverted the order, right? So G1 to G2, G2 to G1, and I divide by the degree of 2. So if I run that, what I'm going to create is a bunch of co-occurrence relationships between pairs of genres that indicate what's the level of overlap between them. Does that make sense? I'm going to take a pause here because it might be a bit, I don't know if counterintuitive, but I think it's pretty straightforward, right? So I'm basically going.
Technically, it's pretty straightforward. Yes, I think I think you have to wrap your head a little bit around what you just described, but I think that's what it is. Andrew asks in chat if dystopia is a subset of fantasy. Can a hierarchical graph be created out of this?
You're reading my mind. Give me 5 minutes and we'll be there. That's exactly what we're after. Because the whole thing here is there's some latent knowledge in my data. So I didn't know that, but it looks like dystopia seems to be a subcategory of fantasy, at least according to my data set. So I want to make that explicit. I'm going to exactly like, who was it? Andrew said.
Andrew, yes.
I'm going to make that explicit. I'm going to create a relationship that connects dystopia and fantasy, saying dystopia is narrower than fantasy, to surface that knowledge that exists in my data and that was not visible to me before. Because then I can use that for many purposes. I can present my data in a tree for navigation. I can do recommendations. I can learn from it. So that's exactly where I'm going. So I want to make that implicit knowledge explicit on my data. So now, this has completed. It took 15 seconds. In the sandbox, it's a bit limited in terms of, but we have if we look at co-occurrence, now we have a bunch of pairs of, instead of looking at that, let's find maybe, for example, a path of length 5, right? And just to see, for the sake of it, not that because it's important, but if we get a path, we see that there's tags that happen and co-occur. So we have historical. It kind of makes sense, right? So historical books, adult fiction, there's overlap with religion, and we can look at what's the size of this overlap. In this case, it's small. It's 0.1%. So that means that only 1% of the books in adult fiction happen to be about religion, right? But
kind of makes sense.
Exactly. Maybe the other way around is different, right? And similar, right? So because remember, this is directional. I don't want to click here because you know what's going to happen, right? It's going to explode and it's going to show me all the books and everything. But we'll exploit that in a minute. But we have this type of relationships, right? So we know that, and this should be pretty big, 40%. So of all Arthurian, which I suppose is King Arthur books, 40% are historical, which makes sense. Maybe others are, science fictions or whatever, or poetry or whatever. But there's a stronger overlap in that direction. So this kind of is taking the first step in that direction. So we're surfacing the co-occurrence, the directional co-occurrence factor. And now I'm going to implement...
maybe quickly before we do that, Peter asks a question. I guess this is we are not we are. I think I'll let you answer it, but I think we are not showcasing this as this is how you do it. This is more like a a way of explaining it. But Peter asks if you have two genres that share 3 books and each has 2 other different books, how does that affect your score? So if it's
so that's exactly what we saw here. So this is the example. So if they share 3 books, but there are 2 that are not shared, that's how it affects the score. You see the 0.6 here. So the overlap is 3, but it's 3 out of 5, right? So this is 60%. Is that the question? Am I understanding?
I'm not 100% sure now. I thought I misunderstood. I thought I understood the question, and I wanted to say we have obviously some holes in the example, and it's not a perfect way of calculating it. But now I realize maybe it's not that. Each genre, now he elaborates on it. Each genre has 5 books. They share 3 books. Each genre has 2 books that are not shared. They are not synonyms, but neither is subordinate to the other. This sounds like a math question I hated back in school. But
Yeah. So in that case, we would get like 3 out of, if the overlap is 3 and they have 2 that are not shared, we will have 0.6 in both directions. So that's absolutely right what Peter is saying. So they would not be synonyms, because to me a synonym is a 1-1, and we're going to implement that in a minute. If 100% of the books in one set are contained in the other and the other way around, 1 in both directions, that means synonyms. 0.6 in both directions does not involve synonyms, that does imply synonyms. So I agree with him. I don't know if it's a statement or if it's a question, but yes, I agree that. So I think we're getting ahead of ourselves. Give me just
yes,
2 minutes, because this is the first step, and now we're going to do exactly what Peter was saying. So 2 are identical and are equivalent, or are synonyms, if we want to call it like that, if the score in both directions is 1. So if we have a genre that has a co-occurrence score of 1 to another one, and then back as well, so as I was saying, all books are contained in one and other set, then they are equivalent. I'm going to list a bunch of them. I don't know how many are there in my set, but there you go. So it's just a few of them, but natural history is the same as biology. Then actually I'm getting the duplicates both sides, the pair in both orders, but conceptually they're not synonyms, but in my data set they are. And that's what I was saying before. Metaphysics is not the same as theory, and that's why we have to take this with a pinch of salt. And I'm not going to merge these two things, but this is for me the definition of a synonym. If we took a complete data set, we could derive that these two things are the same. But because this is an evolving and alive data set, and people keep adding tags, maybe we need to refresh that. But this is how I define a synonym: 1 in both directions, right? If it's 0.6 in both directions, it wouldn't be picked up by this. But the more interesting one is where we don't have 1 in both directions. It's actually when we have 1 in one direction and something smaller than 1 in the other direction, which is exactly what we were seeing in our slide, right? So something like this makes it possible for us to derive that dystopia is a subcategory, or is narrower than fantasy. Because there's 100% in one direction, there's 1, but there's less than 1 in the other direction. And that's exactly what this query returns. So G1 to G2 is 1, but in the other direction, it's smaller than 1. And I'm going to list a bunch of them, and we're going to see if that makes sense. And well, it probably does, right? So Japanese literature, church, LDS, medicine, medical, so it's more a term thing. Marriage, relationships. So I don't think it's completely wrong, right? Comics, graphic novels, and we have I'm listing the score in the opposite direction, the one that is not 1. So in order to see if that makes sense, what I'm going to do is I'm going to materialize them. So I'm going to actually create the relationship, like I think Andrew was saying before. That's exactly the idea. So I'm going to take this, and I'm going to say, whenever there's one of these cases, instead of listing it on the screen, I'm going to actually create a relationship between G1 and G2, saying this is narrower than G2. Boom, there we go. So that should create a bunch of them, not many, but and now we're going to try to explore it. But before we explore that, I'm going to remove shortcuts. What does that mean? So you will see that in some cases, we will have kind of like a triangle. It's probably easier to understand here. So remember that we're going to build something like a taxonomy of a classification of narrower than. So we will find cases where we have a class or a category, a genre in this case, that's narrower than another class, another category, and this is narrower than another one. So it's kind of a 2-step hierarchy. But then we have the bottom one also linking to the top. This is kind of redundant. So I don't need that, because I have the complete path. So that's what this query is doing. So if I have a more than 2 step away connection, and then I have a shortcut, then I'm going to get rid of the shortcut, right? This D that I'm going to call a shortcut, I don't want it, because it's like I say, it's a shortcut that we can derive from the explicit complete link, and that will get rid of 100 of them. So that should be a cleaner data set. But now we have something hopefully interesting to explore. Let's see what that is. So we're going to have genres here. We have genres that are narrower than others. Let's see, narrower than, and I'm going to see if we have, by any chance, I don't know, something like 3 levels deep, maybe. So we'll have another genre here, and I'm going to put that in. Maybe calling it taxonomy is a bit too ambitious, but why not? Let's and limit it to, I don't know, to 5, for example. So let's see what we got here. So doesn't need to be a tree, may or may not be a tree, to be honest, but there you go. So we have nonfiction, and we have some categories. Business is nonfiction.
Yeah.
This seems to be a duplicate. I don't know, business. This is a misspelled one, business. You see,
that's what you get when
productivity. So maybe, because it's manually entered, then have science. Under science, we have health. Interesting. Then there's cooking, nutrition. So it kind of, I'm not saying it's perfect, but that's what our data is telling us. Then we have religion. I mean, this goes up. And that's what I was saying. It doesn't need to be a tree. I mean, it's going to be a graph. And we see church, scripture, yes. So there you go. So I don't think it's completely stupid, right? So it kind of makes sense. And
it does, yeah.
And at least, again, let's keep that in mind. This is based on our data sets. So don't take these as, absolute truth. And maybe grabbing a larger data set or a more balanced data set will give us different results. And, there are other things that we could do, things like introducing thresholds, right? So we're taking any possible overlap, even if there's a single book that's shared between 2 categories. Maybe, in order to have a relationship meaningful, we can say, well, at least they have to share, I don't know, a dozen books, right? If they only share 1 book, maybe that's just a coincidence. So these sort of things that, if we take a more scientific or more serious approach, we would introduce a lot more elements like these. But with a very, very 3-line of code approach, we're kind of capable of having our data set talk and tell us, hey, that's the structure in the data set. And I think that's pretty interesting. And just to complete the session, I was thinking, why don't we go and have a look at that from Bloom? So I don't know if that will, and maybe we can take the opportunity also to answer questions if there's anything that you may want to ask Alex. But so I'll copy this, and hopefully that's going to take us to Bloom. But yeah, the idea, I mean, that's pretty much it. I mean, that's what I had for today's session. So it's just a simple, example of how we can use the tools at hand, whether that's the graph algorithms in GDS, our own, set of query patterns using Cypher. But we can really have our data talk and surface and make explicit these latent bits of information that are in our data, and that we can use, like I was saying, to either propose, how to navigate the data, how to provide recommendations, how to do the kind of things that we did in session 1, right? Session 2, sorry.
Session 2, yeah.
So if I paste that and we connect to the sandbox instance, we should. Yeah.
I mean, obviously, open invitation to chat. So if you have any questions on it, type it in. So for me, this is super interesting because we we didn't define anything of this. The data was just there, and we loaded it in. So we found this out by looking at the data, and I think what you just said is very important. Obviously, if you would do this in another environment, you would look at your data. Is it clean? Does it make sense? Are there typos like busyness and stuff like that? And obviously, but with all of that, you can basically take your data you have in your use cases and just go in and look and see what there is, and then get this ontology set up, and that is sort of
it's
very helpful and very quick.
I agree, and this is it's a way of learning about building. I think it's totally building a knowledge graph, because in this case we started from these tagged data sets, so people have actually entered these tags.
Yeah.
But I mean, nothing stops us from going to our data set. And let me show you another, just a little bit about the books. And again, I connect that with something that we showed. I think it was also on session 2. But we could look at the description, right? The description is a pretty rich fragment of texts, right?
Yep.
So we could go and run the NLP algorithms in APOC. I mean, the wrappers on the AWS GCP algos, NLP methods, and we could do entity extraction on that, right? And for example, let's say, I don't know which book is that, right? So this is Hunger Games, right? So maybe we extract some concepts, we extract, dates, places, locations, and we materialize them in the graph, just like we did in episode 2, right? So we get another source of tags, because
True.
we can take those and then learn from that and classify. So hey, it happens that all books about Italy also, are a subcategory of books about Europe. I mean, sounds, first thing that comes to mind. But these sort of things that are not necessarily coming from tags, but can come from the text. So it doesn't necessarily apply to a catalog of books like this one. It can be really anything. You can do this step of entity extraction, and then you have an ontology, fine, you can link it. You don't have an ontology, maybe try to surface it. You have a class, learn that classification, learn from that set of entities that you've extracted. So it's really an open area for enriching your knowledge graph. And yeah, before, I mean, I wanted to show.
This is, I think, very important. What you just said is if you don't have an ontology, but you might have one sitting in your data and you're not aware of it. This is this is super interesting. If you then create one out of your very own data, you get your very private ontology stream graph set up, and with that that can be helpful for your working with your data, for how you treat it, how you go from there. You can say, okay, I have all my data here, and I kind of, this is already set up in a structured way, but I wasn't aware that there was this ontology hidden in my data, and with that I can adapt that or apply that what I then learned towards my data and how I work with it and how I use with it, how I use it.
And that's and that might, that might be a bit naive, right? This is what
yes,
what Mark Needham called the Barassa algorithm, because it's really simple, but you can add, like I was mentioning, all sorts of heuristics to make that more meaningful, to remove like bias based on on corner cases like the one we're mentioning before. But it's just kind of a starting point, and showing this idea of I mean, there's a lot of there's super rich information in my graph that I can surface and that I can use to enrich my knowledge graph.
And obviously, yes. I mean that is clear. I mean, we have 55 minutes now. We showed a little bit of an example of how you get to somewhere in 55 minutes. Obviously, this is not. We are not suggesting or even saying that this is.
I'm not going to write a scientific paper about that, but it's something that I'm exploring, and I'll probably go a bit deeper on that, because I think it's interesting. And you see, this is the kind I'm showing in Bloom, how you can take, I don't know, I pick historical fiction as one of the labels, and you see that there's a number of of categories that do make sense. I mean, art history, 11th century, Arthurian, World War One. So there you go. That's the kind of information that you get. Baseball, Australia, maybe in a wider data set, Australia will never be a subcategory of historical fiction, but it happens that in my data set, all the books about Australia, and we can see, probably if I expand this and look at the books, there's only 3 books. So of course that explains why only 3 books, and the 3 happen to be about also about historical fiction. So that's the kind of bias that we get by picking a small set.
Obviously,
but
yes.
We could adjust, but that's the idea, and then we can keep expanding. I don't know, what do we have about Spain? We can have all the categories out of it. Where did it go? Oops, I have set the hierarchical organization. So you see, the books about Spain are historical fiction, but they're also tagged as fiction. So that's the kind of relationship that we've generated, and maybe we can explore further. But yeah, I think I'll stop here. But I'll, as usual, all the code will be on GitHub soon, if not already. And that was it for today. I hope that was interesting. And
then there's one more question. Maybe we quickly go go into that from Andrew. Andrew wants a graph ontology database for physics. Is this a map from ontology table text format to graph? What is the best way to format this initial ontology? Can I map from math objects to graph?
Wow, that's I mean, that's a very a much bigger question, I think. So I mean, you can take two approaches. I mean, if you're an expert in physics, you can create your own. I don't know if the question is more in the direction of how do I formalize that, or can I learn it from some text elements? I cannot anticipate the quality depending on what you use as a source. But this idea could be applied to any domain. So if it's specific of the area of physics, I guess you would get a rich classification of concepts in that area. But so table text format, yeah, it could be. I mean, here we clearly loaded a CSV file with lists of documents. It can be really anything, as long as you have a worst case, you can apply, like I mentioned before, right? Like NLP and do entity extraction from these free text. I mean, if you have text format on a table, if it's structured, you have the tags like we had today. If it's unstructured, you can do a step of entity extraction and then use those entities as your tags, as your categories, and then run these classification algorithm. But yeah, I mean, I don't know. This is not specific of a particular area or domain, so these can be applied in any case, I guess.
Yeah. Cool. All right. I just posted a link to Jesus on Twitter, so if you would like to follow him there, leave a follow on his Twitter account, and a link to the repository in chat. So there you can find the previous episodes with the code examples we did. Also, obviously, the YouTube playlist has all the Going Meta episodes from episode 1. Yeah, I think this was interesting and another great episode. Thank you very much, Jesus, for preparing and for sharing.
Yeah, it was a bit of a shorter one because shorter interval because we had the delayed one because of Graph Connect. So
exactly, yeah,
good that we have time to prepare that. But yeah, looking forward to the next one. So that was great, and see you in a month, I guess.
See you in a month, exactly. Take care, everybody. Thank you for watching. Again, feedback and everything else obviously welcome. So leave us a comment, a like. Subscribe to YouTube or anywhere else so you keep up to date. This is the last stream this week, but we will be back on Monday. Michael will go about the Code Golf Challenge, so maybe a quick shout out to that if you are interested in a little hackathon challenge, Cypher coding challenge. It's running since last week. It's called Cypher Code Golf Challenge. So if you want to take part in this, go to the URL I'm posting in chat now, and there you get 3 different Cypher challenges: beginner, intermediate, and expert, and you can win prizes up to $27,000. So it's some money is to be got, and obviously fun to be had. So yeah, thank you for watching. Take care, everybody. Stay safe, and see you soon.